Hi students, I am Sumalata. Welcome to Learners Chemistry. In today's class, I am going to explain about ozone, allotropic forms of sulfur, oxides of sulfur, oxoacids of sulfur and sulphuric acid also. If you want complete information about this lesson, you can check in playlist. I am uploading each and everything. I am giving complete knowledge present in your textbook. So just watch complete video and then mention your words in comment box. Is it useful or not? Is it informative or not? Okay. If you feel useful and informative, please do subscribe, share these videos to known people, like also. Okay. Then we will go to our topic. Ozone is the oxide of an oxygen and also it is the allotropic form of oxygen. It is formed from generally atmospheric oxygen in presence of sunlight. That atmospheric oxygen converts into the ozone. Generally, this ozone layer protects the earth from harmful radiations. If you observe sea level, from sea level to 20 kilometers, their ozone layer present. Up to limit, nothing but 100 below 100 ppm ozone concentration is there, that is okay. But if it is more than 100 ppm, that will leads to the breathing problems. It results to the headache and nausea. Laboratory preparation methods you can see, that is silent electric discharge of oxygen. Silent electric discharge oxygen will gives you ozone. Here energy delta H equal to plus 143 kilojoule per mole energy will be released. Here silent electric discharge is necessary for the formation of ozone from oxygen. Why? Because this silent electric discharge protects the decomposition of ozone back to oxygen. Nothing but here I indicated a reversible arrow because oxygen converts into ozone as well as ozone converts into oxygen, so that the to prevent the decomposition of to prevent from the decomposition of ozone into the oxygen. So we are using silent electrical discharge, and also in during this method we got only up to 10% only, 10 ppm only. If you want more than 10%, we need to use ozonizers, then we will get more concentration of ozone. This is here the formed ozone is the ozonized oxygen also we can call. Okay, this is the laboratory preparation methods. If you see, ozone is the three states it will available. One is liquid form, gaseous form, second one is liquid form, and third one is the gaseous form. Okay, this all these three states will have different colors. If you see ozone, harmful effects from where it is getting, nothing but supersonic airplane jets. If you take, they will release some pollutants. In that pollutants, especially you can take nitric oxide. That nitric oxide reacts with ozone. Nitric oxide reacts with ozone. It will gives you nitrogen dioxide and oxygen. So see, the formation of oxygen from ozone is this is very dangerous thing to our environment. And also ozone can also be decomposed into oxygen and nascent oxygen. The formation of nascent oxygen and ozone from formation of nascent oxygen and oxygen from ozone is the exothermic reaction. Why? Actually, while forming these two things, some energy will be released. That energy indicates with the enthalpy. For the formation, for the decomposition of ozone, for the initiation of this reaction, it will need some energy. We are going to supply some energy, that is the entropy. So entropy and enthalpy will becomes Gibbs free energy. So that Gibbs free energy here will become more. If Gibbs free energy is more, that will be the exothermic reaction, explosions will be happens. So that this is the harmful reaction to the environment. See, this is the I mean supersonic air jet planes released nothing but some pollutants. From that pollutants, especially nitric oxide reacts with ozone, will gives you nitrogen dioxide and oxygen. These two things also, here these two and this one also going to the deplete the ozone layer. And also aerosol sprays we are using. These aerosol sprays are having freons. Freons are nothing but chlorofluorocarbons. These are also harmful things to the depletion of ozone layer. So if you I mean this is about laboratory preparation method for ozone, and also these are the harmful reagents, and its melting point is 385 Kelvin. Its ozone melting point is the 385 Kelvin. Coming to next one, it's ozone acting as a oxidizing agent. You can see few examples about this one. It will oxidize as black lead sulfide to white lead sulfate, PbSO4 plus 4 moles of oxygen. So that here you need to take 4 moles of ozone, that will gives you white lead, that will converts the black lead sulfide to white lead sulfate. And also it will oxidize mercury to mercuric oxide. Hg plus O3 will gives rise to Hg2O and oxygen. This reaction also known as tailing of mercury. Why? Because it will converts into mercuric oxide. This mercuric oxide sticks to the walls of the test tube. During this procedure, mercury loses its meniscus, so that this process is known as the tailing of mercury. And also it will oxidize iodide to iodide to iodine. See, potassium iodide converts into potassium hydroxide, and iodide ions converts into iodine, and also oxygen, and also oxygen. Okay, another one is it will oxidize silver metal to silver oxide. It will oxidize silver metal to silver oxide. See, this is the silver oxide. Okay, this is the silver metal. And also one more reaction, ozonolysis of ethene. You can take ethene, that ethene converts into CH2 double bond CH2. Here you are going to use ozone. It will oxidize this ethene during the formation of ethylene ozonide. See, this is the ethylene ozonide. Then it will decompose into formaldehyde. 2 moles of formaldehyde will form, and also hydrogen peroxide. This is the hydrolysis in presence of zinc dust as a catalyst. Okay, these are the oxidizing reactions of ozone. This is about ozone, and then we will go to about sulfur, allotropic forms of sulfur and oxides of sulfur. If you see allotropic forms of sulfur, generally it will form so many allotropic forms. Especially we are discussing about two allotropic forms. Those are yellow rhombic sulfur and monoclinic sulfur. Yellow rhombic sulfur, also known as alpha sulfur. Alpha sulfur. This is known as yellow rhombic. And another one is the monoclinic sulfur is the beta rhombic. Okay, its melting point is 385.8 8 Kelvin. Its specific gravity is 2.06. Specific gravity is this one. It is formed from the evaporation of carbon disulfide solution. Then alpha form of sulfur will form. Alpha sulfur will form. Here it is evaporation. Okay. Here in this carbon disulfide solution, sulfur is present in the form of rolling sulfur. Rolling sulfur present in carbon disulfide, that will going to be evaporated, and then alpha sulfur will be formed. It is soluble in CS2 carbon disulfide, insoluble in water. It is insoluble in water, and you can see sparingly soluble in some organic solvents like benzene C6H6, ether ROR, and also alcohol ROH, alcohol. Okay, you can indicate this is benzene, ether, and alcohol. Okay, it's and also its transition temperature and nothing but up to 369 Kelvin temperature it is going to be exist. 369, why I told you, you will get while explaining beta sulfur. Okay. Then coming to beta sulfur. Beta sulfur is also known as monoclinic or beta sulfur. It is its melting point is 393 Kelvin. Specific gravity is the 1.98 specific gravity. It is formed from by heating alpha sulfur. If you heat alpha sulfur, then you will get beta sulfur. Generally, how we are here, the procedure is different. In laboratory, you need to take watch glass. In that watch glass, you need to put alpha sulfur. That alpha sulfur going to be heated. While heating, the alpha sulfur becoming ash. That ash formed in the form of crust. Okay, crust. That crust, while removing that crust, before that removing crust, 2 holes you need to do on that crust, because any liquid form is there, it will going to be come out. Then after removing the crust, you will get needle shaped beta sulfur will be formed. Okay. Yes, this is about the formation of beta sulfur. It will be soluble in CS2 carbon disulfide. It will be soluble in carbon disulfide if the temperature is up to 369. Nothing but if the temperature more than 369, alpha sulfur becomes beta sulfur. If the temperature less than 369, beta sulfur becomes alpha sulfur. So that at this temperature both are going to be stable, alpha and beta. So that the 369 temperature is known as the transition temperature. Transition temperature. Okay. Both these sulfur forms are present in a S8 form. S8. See here I am writing S8 form. S8 form. Both are present in S8 form. Its structure is becoming like a crown shape. Puckered ring shape is nothing but crown shape. You can observe that structure here. This is one sulfur. This is another. This is another one. See. 1, 2, 3, 4, 5, 6, 7, 8. See, this is the crown shape or puckered ring structure, and all this, this structure applicable for both alpha as well as beta, because both are having S8 atomic state. So if you take modified forms of sulfur, S6 to S20 is there, modified forms. You can that means if you take S6 structure, that S6 structure like this, S6 sulfur, see this is the modified form, this is the modified form, this is S6, this is the structure of S6. Okay, sulfur, next coming to the, this is about allotropic forms of sulfur. Then we will move to sulfur dioxide. Next you can take sulfur dioxide. This is the oxide form of sulfur. Oxide form of sulfur, it is colorless gas and pungent smell, it is having pungent smell. It is going to be react with both water as well as alkali. While reacting with water and alkali, it is going to be behave like a carbon dioxide. Okay, first of all you can see preparation methods. Before that preparation methods, it is having two canonical forms. Those canonical forms are, see this one, this is sulfur double bond O minus, this is one form, and another one is this is. These two are the canonical forms of sulfur. Then coming to the preparation methods of sulfur dioxide, generally sulfur reacting with oxygen, sulfur reacting with oxygen, sulfur dioxide, sulfur in the form of solid, sulfur dioxide will be formed. That sulfur dioxide, along with this one you will get sulfur trioxide also, but that will be the least amount, very minute amount, so that you will be neglect I mean that will be negligible amount, so no need to write. So what is this? See, sulfur in the form of solid reacting with oxygen, it will gives you sulfur dioxide. This is one preparation method. And second one, you can see second one, sulfite ions, SO3 2 minus ions reacts with diluted sulfuric acid, you will get sulfur dioxide and also water. Okay, this is one preparation method. And also sulfur dioxide is the one of the byproduct in while doing ores extraction, that is especially iron ores you can take, FeS2 iron sulfide 4 moles you can take, 11 moles of oxygen you can take, then you will get Fe2O3 iron oxide and 8 moles of sulfur dioxide. These are the three important preparation methods about the sulfur dioxide. And then you will go to its chemical reactions. Sulfur highly soluble in water. So I am writing here chemical reactions. Here nothing but chemical reactions highly soluble in water. So you can write SO2 reacts with water, it will gives you H2SO3, sulfurous acid. Okay, it is also reacting with sodium hydroxide, 2 moles you can take, Na2SO3 plus H2O, Na2SO3 plus H2O. Sodium sulfite will form. This sodium sulfite again reacts with excess of sulfur, SO2 plus Na2CO3 plus H2O. Okay, will gives you 2 moles of NaH. So here you can write 2 moles NaHSO3, sodium bisulfite, that's it only. Okay, it's balanced. See here it is the SO3, not CO3. Okay, SO3, Na2SO3. See, no need to take 2 moles because here one sulfur, here one sulfur. 2 oxygens, 3, 6 oxygens enough, 2 hydrogens. Okay, this is about sulfur reaction with sodium hydroxide and with water. While reacting with water and sodium hydroxide, nothing but water and alkali, it is behaving like its behavior just looking like a carbon dioxide. Okay, and also sulfur oxidizes iron plus 3 ion, not oxidizes, reduces. Sulfur reduces iron plus 3 form to the plus 2 form. You can see that reaction also here. I'm writing on 2 moles Fe plus 3 you can take SO2 and H2O, 2 moles of H2O. So Fe plus 3 converts into Fe plus 2. So it will become SO4 minus 2. So you can write here 2 oxygens, here 2 oxygens enough, plus 4 moles of H plus, 4 moles of H plus C, SO4 minus 2. And also it will decolorizes the permanganate ion, see that reaction also. 2 moles of SO2 you can take, and 2 moles of 2 moles, not 2 moles, 5 moles SO2 you can write here. MnO4 minus plus H2O 2 moles. So you will get 5 moles of SO4 minus 2 sulfide ion, next sulfate ion, and then 2 moles of Mn plus 2, and then 4 moles of H plus ions. See how many oxygens? 4 2s, 2 4s 8, 5 2s 10, 20 oxygens completed, 4 hydrogens and 2 manganese, Mn plus 2 ions. Okay, this is these are the these two for reduction reactions. Here sulfur acting as a reducing agent, reduction. Here also reduction. These are all oxidizing reactions. Okay, this is about sulfur dioxide. It is used as a bleaching agent and also anti-chlor and also disinfectant, and these are the uses and chemical reactions of sulfur dioxide. Then we will move to nothing but oxoacids of sulfur. Oxoacids of sulfur especially you can take. Okay, I will rub this. We can go to discuss about few oxoacids of sulfur. First one you can see H2SO3. This is the sulfurous acid. If you check this structure, double bond O, yes, OH and OH. See H2SO3 enough. Okay, next sulfuric acid H2SO4 you can take, that is S double bond O, OH, OH and S double bond was. Okay, SO4 and 2 hydrogens enough. Next peroxysulfuric acid H2 S2O8. Peroxysulfuric acid you can see peroxy bond is there present between 2 sulfur atoms. So this one. Okay, here double bond O, OH, double bond O, OH. Okay, how many oxygens completed? 1 2 3 4 5 6. So 1 2 remaining, 2 more oxygens. So now it's completed. 1 2 3 4 5 6 7 8 oxygens, 2 sulfur atoms and 2 hydrogen atoms. Peroxysulfuric acid. Next one, pyrosulfuric acid. You can see pyrosulfuric acid H2 S2O8. H2S, not O8, O7. This one is O7, H2S2O7. Yes, OS. Sulfur, oxygen sulfur bond is there here. Double bond O, OH, OH, double bond O, double bond O. 1, 2, 3, 4, 5, 6, 7 oxygens, 2 hydrogens and 2 sulfurs completed. Sulfurous acid, sulfuric acid, peroxysulfuric acid, pyrosulfuric acid. This pyrosulfuric acid also known as oleum. Oleum fuming sulfuric acid. This is also known as oleum fuming sulfuric acid. Okay, this is the peroxysulfuric acid. Peroxysulfuric. This is sulfuric. Sulfuric, and this one is sulfurous. sulfurous. Okay, then we will move to making of oleum or sulfuric acid. Especially from this one we are going to be extract sulfuric acid. So manufacturing of sulfuric acid, we can see manufacturing of sulfuric acid. You can see first of all here two preparation reactions are there, and then we will go to chemical reactions. While discussing IP based questions, there I will go to explain in detailed manner each and every step, because it will comes for maybe 8 marks sulfuric acid preparation method, so that where I will give you complete information about IP based. Okay, here we are discussing about only objective, so that I am giving you preparation methods and chemical reactions only here. Okay, so sulfur dioxide reacts with oxygen, you will get sulfur trioxide, SO3, sulfur trioxide. Here energy delta H is the -1, gives you minus 196.6 kilojoule per mole energy. Okay, this the formed sulfur trioxide SO3 reacts with H2SO4. You will get the fuming sulfuric acid. H2S2O7 is the fuming sulfuric acid, is nothing but oleum. Just now we have discussed about it. Okay, from this one we are going to extract sulfuric acid. This is we are sending this one, but we are getting, this is the getting one, this is the sending one. Okay, then coming to chemical reactions of sulfuric acid, you can see sulfuric acid oxidizes the metals as well as non-metals, and also it will dehydrate some organic compounds also. You can see those reactions. First one I am writing here, C12H22O11. If you dissolve this compound in H2SO4, concentrated H2SO4, you will get CO2, carbon dioxide and water. This is H22. Okay, 11 moles of water. Okay, it will separates the water from organic molecules, so that it will completely decomposed. It will completely oxidized, means it will completely decomposed, and then it will oxidizes non-metals. If you take sulfur, concentrated H2SO4, you will get here 2 moles you can take, 3 moles of SO3. Sulfur trioxide will form how many? 3 3s are 9, 3 4s are 12. SO2 you can write SO2. Yeah, this is SO2, and how many water molecules here? 2 water molecules. Is it balanced? 3 2s are 6, plus 2 8. Yes, it's balanced. Only 2 sulfur atoms, 4 oxygen atoms, 4 hydrogen atoms. Okay, it will also oxidizes carbon. Here also 2 moles H2SO4 you can take, that will gives you carbon dioxide and water and oxygen. Okay, water and oxygen. See, 4 2s are 8, 2 8 oxygens are there, so that here sulfur dioxide SO2 you can write 2 moles of SO2, then it will become balanced. 2 moles of SO2, 4 oxygens plus 2 plus 2, 8 oxygens, 2 sulfur atoms, 1 carbon atom. Okay, these are about chemical reactions with these are the non-metals. See, these are the non-metals, this is the organic compound. You can take one example for metallic reaction. See, it will oxidizes metals also. Copper reacts with sulfuric acid H2SO4. Listen here, in all these 3 cases we need to take concentrated sulfuric acid. Okay, copper converts into copper sulfate CuSO4, then water, 2 moles of H2O, and also sulfur dioxide. Okay, these are all about first one we have discussed ozone, then after allotropic forms, then after sulfur dioxide, and then after oxoacids of sulfur, and then sulfuric acid preparation methods and properties. I think you are all understand about it. If you feel useful and informative, please do subscribe, share these videos to your known people, mention your words in comment box, like also. Okay, thanks for watching. We will meet in the next class. Bye all of you.